This is lesson 5.2, which is on solving equations with variables on both sides. So previously we've learned about solving equations when we just have a variable on one side, but now we're going to be working with both sides of the equation. So there's two warm-up problems. You'll want to pause this, try them on your own, and then resume and we'll go through it together. So number 1 says the area of a triangle is 12 square feet. The width of its base is 6 feet. Find its height. So we know the formula for area is 1/2 base times height. It tells us here that the area is 12 square feet. So I'm going to plug in 12 for A equals 1/2 times the width of its base. So we know the base is 6 feet and we need to find the height. Well, when I simplify this, I get 12 equals 1/2 times 6 is 3h. Well, to get h by itself, I have to do the inverse of 3 times h, which would be to divide both sides by 3. So this leaves me with h equals 12 divided by 3 is 4, and we're working with feet here. So the height is 4 feet. Number 2 says the perimeter of a rectangle is 26 meters. The width of the rectangle is 7 meters. Find the length. So we know that perimeter of a rectangle is 2 times the length plus 2 times the width. We're given that the perimeter is 26 meters, so I'm going to plug in 26 for P. We're given that the width is 7, so 2 times the length plus 2 times 7, and we're going to solve for the length. Well, 2 times 7 is 14, so this becomes 2 times the length plus 14 equals 26. Then I need to get rid of that plus 14, so I'm going to add negative 14 to both sides, which again is the same as subtracting. And I'm left with 12 equals 2 times the length. Well, in order to get length by itself, I'm going to divide both sides by 2, and I get that the length equals 6. And my label here would be meters. So the length is 6 meters. Okay, so in your note packet, we're going to start with the algebra triple O, which we talked about this before, the order of operations where we had add op, distribute, combine like terms. We used that when we simplified. Then when we solved, we added get rid of the constant, get rid of the coefficient, and check. Well, here's where this is a little bit different. We're still going to have add op, then distribute, then combine like terms, but then the next step is to get the variables on one side. After we've gotten the variables on one side of the equation, then we're going to solve by getting rid of the constant, then getting rid of the coefficient, and then as always, we want to check our answer. So just some tips here. When solving equations with variables on both sides, get the like terms on the same side of the equal sign. So use inverse operations. So here's an example, and it's already typed out and it got a little bit funky. But we have 7n minus 5 equals 10n plus 13. And you don't have to write this down because we'll practice. But the first thing we'll want to do is add op, distribute, combine like terms. Yep, so then we got to get variables on one side. So what they did here is they took away 7n from both sides, and we'll be adding negative 7n. And that left us with 3n, and then we have negative 5 equals 3n plus 13. Well, then we want to get all the constants on one side. So then took away negative 13 from both sides, and was left with the negative 18 equals 3n. Then divide both sides by 3 and you get negative 6 equals n. So let's practice that because when we practice, it'll make a lot more sense. So in your notes, you'll want to write down this example. 8y plus 4 equals 11y minus 7. First thing I'm going to do is add up. I can't distribute, I can't combine like terms, so now I want to get the variable on one side. So I want to work with a positive variable, so I'm going to take 8y away from both sides. So I'm going to add negative 8y to both sides, which is the same as subtracting. And I'm left with 4 equals 3y plus negative 7. And remember, I always want to see work on both sides of the equal sign. Now, to get rid of that negative 7, to get rid of that constant, I'm going to do the opposite, which would be adding 7 to both sides. And I'm left with then 3y on this side, and 7 plus 4 is 11. So 11 equals 3y. Well, now to get y by itself, I'm going to divide both sides by 3. And I'm left with y equals 11 thirds. We could also put that in a mixed number. 3 goes into 11 3 times with 2 left over, so it'd be 3 2/3. And then the next one, we'll check our work on the next one since it's a little bit nicer. So the next one I want you to write down is m minus 1 equals 9m plus 15. So again, first thing we want to do is add up. Can't combine like, or can't distribute, can't combine like terms. So now I want to get the variables on one side. So I'm going to add negative m to both sides, which is the same thing as subtracting m. And I'm left with negative 1 equals, and then 9m take away 1m would be 8m plus 15. Now I need to get rid of my constant, a positive 15, so I'm going to add negative 15 to both sides. I'm left with 8m on this side equals negative 1 plus negative 15 is negative 16. Then to get m by itself, I'm going to divide both sides by 8. And I'm left with m equals negative 2. And now I can check my answer. So I'm going to plug in negative 2 to the top. So let's see here. Negative 2 plus negative 1, does that equal 9 times negative 2 plus 15? Well, let's see. Negative 2 plus negative 1 is negative 3. 9 times negative 2 is negative 18 plus 15. Well, hey, guess what? Negative 18 plus negative 15, I'm sorry, negative 18 plus positive 15 does equal negative 3, which means they equal the same thing. So yes, m is equal to negative 2. The next one you should write down is this: 6k minus 34 equals negative 6k plus 14. First thing I'm going to do is add up. Can't distribute, can't combine like terms, so I'm going to get these variables on the same side. So what I'm going to do is I'm going to add 6k to both sides, since the opposite of negative 6 is positive 6. And I'm left with 12k plus negative 34 equals 14. I'm going to get rid of that negative 34, so I'm going to add 34 to both sides, because that's getting rid of my constant. And I'm left with 12k equals 48. Then I'm going to divide both sides by 12. And I'm left with k equals, and 48 divided by 12 is 4. Okay, on the test, make sure you're always checking your answer. Then, on the next one here, we have negative 1/3 x plus 3 equals 1/4 x plus 24. So the first thing that I want to do here is I want to get my fractions to have a common denominator. So I see 3 and 4 and I think 12. So I'm going to rewrite this to be out of 12ths. Well, 3 times 4 is 12, so 1 times 4 is 4. So this is negative 4/12 x plus 3 equals, and then 4 times 3 is 12, 1 times 3 is 3, plus 24. Then what I'm going to do is I'm going to add 4/12 x to both sides, since the opposite of negative 4/12 is positive 4/12. Oops, and that should have an x with it. And that leaves us with 3 equals 3/12 x plus 4/12 x would be 7/12 x plus 24. And then what I'm going to do is I'm going to take away 24 from both sides. I'm going to take away that constant, so I'm going to add negative 24 to both sides. and I'm left with negative 21 equals 7/12 x. And then remember, to get rid of a fraction in front of a variable, we want to multiply both sides by the reciprocal. So I'm going to make brackets here, and the reciprocal of 7/12 is 12 over 7. And then I'm going to put negative 21 over 1. And to solve this, this is going to give me x. And then I'm going to cross simplify here. So 7 goes into 7 once, goes into negative 21 negative 3 times. And then I take 12 times negative 3, which is negative 36. And again, on the test, always make sure that you're double checking your work. All right, a real life example here says at a carnival you spend $6 on food and buy 12 game and ride tickets. Your friend spends nothing on food and buys 20 game and ride tickets. You both spend the same amount of money. All of the game and ride tickets cost the same amount. How much does each ticket cost? So here's the deal. We know that we're spending the same amount of money, so I'm going to write two separate equations on both sides. So for me, I spent $6 on food, so that's a one-time, and 12 game and ride tickets. So I'm going to write as 12x, 6 plus 12x. And my friend didn't buy any food, but they bought 20 game and ride tickets. So I'm going to write that as 20x. You could also use a different variable here if you wanted, but can't add up, can't distribute, can't combine like terms. So now I need to get the variables on one side. So what I'm going to do is I'm going to add negative 12x to both sides. And again, I always like to keep the variable positive, so that's why I'm taking away the 12x. So I'm left with 6 equals 8x. Now, in order to get x by itself, I'm going to divide both sides by 8, which leaves me with x equals, and then you wouldn't say like 6/8 of a dollar. So I'm going to divide 6 by 8 so that I can get a decimal. Well, 8 goes into 6 0 times, so slide up a decimal, add some zeros. 8 goes into 60 7 times. 7 times 8 is 56. Subtract and I get 4. Bring down a 0. 8 goes into 45 times. 8 times 5 is 40. And so I know that my answer is 75 cents. So each game and ride ticket is 75 cents. The last problem here says to find the perimeter of the square. Well, we know that with a square, all the side lengths are the same. If all the side lengths are the same, that means 2x is going to be equivalent to x plus 4. So what I'm going to do is I'm going to set these equal to each other. 2x is the same as x plus 4. I'm going to solve for x, and then I'm going to find my perimeter. So 2x equals x plus 4. Well, I'm going to take one x away from both sides. Whoops. And I'm left with x equals 4. Okay, so we know that x is equivalent to 4, and we know that one side is 2 times x. So we know that one side is 2 times 4, since x is 4, which is 8. Well, if I know one side is 8, I'm going to take 8 times 4, because there's 4 sides in the square, and my answer would be 32. I don't have a label, so I'll just attach units to that.